Without the ozone layer, ultraviolet radiation can reach the Earth, where it can contribute to skin cancer, crop damage, and the destruction of marine life. So, countries came together, and 25 years ago, the Montreal Protocol banned the use of CFCs, or chlorofluorocarbons, in things like aerosol sprays and fridges. But this doesn't mean the problem's solved, or that the hole is closed. And now, Professor Jim Anderson from Harvard University in the US has just published a study in the journal Science that raises concerns that ozone in the atmosphere is under attack again. And this time it's not limited to the poles. We could be losing the protection around the world. His work shows that stormy summer weather is changing conditions up in the stratosphere and leading to ozone destruction. He's been working in the field for many years, and he says he's concerned with what he's seeing.
The story starts over the Antarctic. We developed the instrumentation that flew on the U-2 spy plane that flew directly into the Antarctic ozone hole in 1987 and established unequivocally that it was indeed chlorine radicals and bromine radicals extracted from CFCs and halons that were the culprit in the chemical and very rapid chemical removal of ozone. Now, interestingly, at that juncture, in the late 80s, we firmly believed it was ice crystals that were created in the lower stratosphere of the Antarctic because of the extreme cold. But, of course, our attention immediately moved to the Arctic once we'd solved the Antarctic problem, and we discovered that there was considerable loss of ozone in the Arctic. But interestingly, the Arctic is marginally warmer in the lower stratosphere in the winter than is the Antarctic. And as studies became more and more sophisticated, it became clear that the real workhorse in this was a very simple binary sulfate water aerosol. And the emphasis in these aircraft measurements shifted toward the climate and away from ozone studies. But the real message coming out of those studies in the early 2000s was that any time you satisfy the conditions of cold enough temperature and or a high enough water vapor concentration, the key chemical reactions on liquid water aerosols initiate this conversion of the inorganic forms of chlorine to free radical form that then attacks ozone.
Does that mean then that this could be happening in areas other than the Arctic and the Antarctic? If we've always assumed that these were reactions that needed cold to happen, then it would make sense that they're limited, but perhaps this is showing that they're more widespread.
That's right. It's exactly right. We began to focus on the climate, and we began to study the convective injection of water into the upper troposphere.
Now, what does that actually mean, this injection of water vapor?
Well, first of all, normal storms that you see day in, day out worldwide have a vertical extent to them. And that vertical extent is the source for delivering water into the upper troposphere. And of course, the troposphere is below the ozone layer. So we're in the midst of a series of these aircraft missions over the United States. And to our shock, we discover that water vapor from these storms over the middle and eastern part of the United States are injecting water vapor far higher than we ever expected. They're 5-6 kilometers into the stratosphere. A complete surprise. We never expected this. But you can see the unfolding story here. That convective injection raises the water vapor concentration within the ozone layer to a level that at typical temperatures initiates the same chemical reactions that we know occur over the Arctic. And now we have a clear coupling between climate change and ozone loss, but that's ozone loss over the United States in the summer, not ozone loss over the Antarctic or the Arctic in the winter.
So you believe that these two things that have always been believed to be completely unlinked, depletion of the ozone layer and climate change, are in fact linked?
We spent 30 years trying to clarify the difference between carbon dioxide and CFCs and between climate change and ozone. Now, ironically, we've come to realize that, in fact, there is a direct coupling from climate into ozone. Climate forcing by carbon dioxide through climate change to severe storms to the injection of water to the fundamental shift in the chemical reactions of the lower stratosphere that control ozone.
Professor Jim Anderson, the head of the Anderson Research Group at Harvard University there. Although he only studied the atmosphere above North America, there's no reason to suspect that the same thing isn't happening globally. And if the cause is climate change, then of course a fix is going to be much harder than just the ban on CFCs like last time.